Hey guys, okay, this is the video on the ambiguous case. So we're going to take the law of signs and we're going to extend it to something called the ambiguous case of triangles. And from the ambiguous case of triangles, you can either make 0, 1, or 2 possible triangles given the information in a picture. So in the little purple box down here, it says the ambiguous case arises when you are given the lengths of 2 sides of a triangle, so maybe like a triangle that looks like this. And an acute angle opposite the shorter of the 2 sides. Okay, so here we go. We've got an acute angle opposite one of the sides, and then that one's going to be acute as well. Okay, so this can lead to 2 possible triangles, and I'll show you how. So the ambiguous case rests upon the concept that sine is positive in 2 quadrants. So if we have a coordinate plane here, right, and we have all students take calc, who's positive in the first quadrant, all of the angles, who's positive in the second quadrant, sine is positive. So that means that if we are trying to use inverse sine to figure out what an angle measure could be, it could be the first quadrant version of that angle, or it could be the second quadrant version of that angle. So I'll show you how this would happen in math. So I have this as my triangle, right? And I'm going to try to figure out what theta is. So I have the sine of theta goes to 3 as the sine of 81 goes to 7. So since 81 is in degrees, I'm going to make sure my calculator is in degrees. All right, I'm good. So I've got 3 times the sine of 81. And that's going to give me this divided by 7. So I have this as my sine of theta equals this trig ratio right here. So there are 2 angles that yield this trig ratio. There's an angle in the first quadrant and an angle in the second quadrant that gives me this trig ratio of 0.423295. So what I'm going to want to do here is inverse sine both sides to try to figure out what that magic angle in fact is. And it is 25 degrees. So theta is 25 degrees. Now remember, it's a 25 degrees in the first quadrant, or it's a 25-degree reference angle rotated into the second quadrant. And the way we would figure that out is do 180 minus 25. And this could also be an angle of 155. Okay? So there are 2 possible angles that this could be, 25 degrees or 155 degrees. Either way, the sine of both of those angles are exactly the same. Look at my calculator, right? So let's see if 2 possible triangles, 1 possible triangle, or no possible triangles could be made with a picture like this. So I've got 2 possible triangles arising here. I've got one where theta is 25 degrees, and then I've got one where theta is 155 degrees. What I need to do is make sure that there's enough degrees left in that triangle to have a third angle, right? So I've got my pictures here. I'm just kind of like copying them from the left. Okay, I've got my pictures here. And what I'm trying to see here is if I do 81 plus 25 and I subtract it from 180, will there be enough degrees left over for a third angle? And there will. There will be 74 degrees left over for a third angle. If I do the same with this, so this is a possible triangle. I'm amped. Great. If I do that with this other way, like let's say this is way number 1 and this is way number 2. If I do it with way number 2, I do 180 minus, and then I have 155 plus 81, and I get a negative number. There can't be negative degrees over here, so this triangle is not possible. But do you see how an ambiguity arises? Because a trig ratio could yield 2 possible angles, a 25 degree or a 155 degree, okay? And it's still an equivalent ratio. So that's the ambiguous case of sines. Let's do an example problem. What's a good one here? What is one that's gonna make you think? 4. Okay. So it says, consider the triangle ABC where, and then it looks like I gotta draw the picture. A, B, C. Where AB is 10, BC is 7, and CAB is 30. Find the two possible values of ACB. Okay, so I'm always going to start with the law of signs. That's where the ambiguous case arises from. So I've got the sine of 30 goes to 7, and then ACB is this angle here, and that's what I'm trying to find. Okay, so we have the sine of ACB goes to 10. So I'll do 10 times the sine of 30. That'll give me 5. Divide by 7, divide by 7. Sine of ACB is equal to 5 over 7. I got to do inverse sine to find what the actual angle is. And let's see, it looks like we're in degrees. So I'm in degrees here, perfect. Okay, so I'm going to do the inverse sine of, ooh, they're moving lots of desks, 5 over 7. And I have 45 degrees. So 45 degrees, think of that as like your reference angle, right? So ACB could be 45.5847 degrees in the first quadrant. Now let's see what he could be in the second quadrant, and then see if we have enough degrees left over to make 2 triangles, 1 triangle, or 0 possible triangles. The problem says find the 2 possible values, so I feel like, I don't know. We'll take a look. So the first possible value is going to be 45.6 degrees. To find the second possible value, I'm going to do 180 minus that number there. So I've got 180 minus that number there. And I will get I'll get 134.4.15. Okay. So the other possibility is 134.415. So the 2 possible values of ACB are 45.6 and 134 actually 3 sig figs, it's just 134. Okay. Those are the 2 possible values. And then now 4B says, hence, find angle ABC given that it is acute. Find angle ABC given that it is acute. Given that it is acute, so ABC is acute. If ABC is acute, we are going to have to use the 134 version. How come? Check it out. If I did 30 plus 134, that'll give me 164. So 180 minus 164 is going to give me 16 degrees left over for an acute angle. If I did the other one where I was like 30 plus 45.6, that's going to leave me with an obtuse angle. And that ain't going to work. That's not what they want. So I got to give the people what they want. That would be obtuse. Can't use that. Therefore, ABC is acute, and it is 16 degrees.